So hi everyone, and thank you for joining this session. I was already introduced, but a few words about me. So I'm Yuval Fernbach. I'm a co-founder and a CTO at Qwak. Before that, I was at Amazon Web Services. I was part of the SageMaker group, and I was leading that area across Europe, Middle East, and Africa. And before that, I was the CTO of the IT department of the Israeli Defense Force. In this session, I want to give you my takes about how to make your models part of the production environment, how to eventually make sure that models affect your production, affect your product eventually, and how to make sure that you do that efficiently. Then we talk about basically at least my takes about production-first approach, how to do that, how to be more efficient with your model building. What is building a model? What, at least to my eyes, is the major challenges with building models, and how to make sure that models are built correctly. Then we'll talk about some model serving challenges. What product expect from models, and how to make sure that models actually achieve that. And eventually we'll show some demos of some of the things that we have in Qwak, how in Qwak we solve that, and have some time for your questions. So I want to start with production ML. Why is it so complicated? And why so many companies, it takes months till models are part of their product. And why I'm saying part of the product is because I do believe that models can give a lot of values. There are models that are relevant for batch processing and can give values in a batch way, basically. And in those cases, usually the models are not really part of the product. But many use cases like churn or lifetime value of customers, those are things that models can solve without really being integrated to the product itself. But usually, once you want models to really give you the edge versus your competition, you need the model to be part of the product itself, and then it becomes more challenging. And part of the challenge is that data scientists or the building phase of models is not enough. Even if you get to great metrics for a model, usually it's not enough. And to actually make the model part of your system, you need multiple stakeholders. Like the data scientist usually will build the model itself and try to get to a specific metrics. And then you'll need data engineers to create the data, both for training and for inference. By the way, usually it will be from different data sources. So that's all like other challenges that I won't speak about today. You need DevOps or MLOps to actually track the infrastructure of this model or build the infrastructure for this model serving and model training. You will need the software engineers to actually integrate between the backend and the models. So there are so many different stakeholders that eventually even, let's check if this works. No, it doesn't work. So eventually, even if the, let's say, data scientist built an amazing model, and it took him or her 3 months to build that model, then you will need like more months just to integrate that and rebuild the infrastructure and make sure that you have the data in production to actually integrate that model to the production environment. And what we are trying to do in Qwak and help our customers do is to streamline this process. And first of all, help the customers to build for production first. And second, make this process easier to use and more robust. So Qwak built this platform, and I won't talk too much about Qwak, more about the processes themselves and how to solve them, but build this platform that eventually focused on helping customers, helping companies to build directly for production and make sure that the models affect their product and eventually give results. And we are working with dozens of customers right now and helping them to do that and to eventually get to models as part of the product. So let's start with talking about models and how to build models, or actually even before that, how companies usually build software. So this is a At least I think the first phrase is from Wikipedia of what is a build system. And what is a build system? So eventually a build system is a process that converts the code to an artifact, right? Converts a code that an engineer wrote and makes an artifact that should be deployed to production. So to create this artifact, you will need to run this process that includes different steps, like managing the versions of the code, like managing the quality or testing the quality, nowadays even the security of the code, making sure that the code can be compiled and actually run the compilation, test that the code is working as expected, and install all the dependencies of this code, right? So if I have a Java code and I want to build it, I will run this build process, and eventually I will get a jar or a Docker container that have all the requirements, the dependencies, that have the compiled version of the code and was tested. And unfortunately, with machine learning, the process usually looks a bit different. Like usually when you ask a data scientist, how do you build a new version, the answer will be, I train the model. And that's usually the process. And what I've seen many companies do, both at my work at the IDF, also at Amazon, and even now at Qwak, is that companies don't look at machine learning, at those artifacts, as a production code, as something that need to be deployed in production and actually serve customers. And I do believe that eventually the same processes that let's call it traditional code go through should also be adopted for machine learning. So for example, for machine learning, there are still dependencies. And actually models are usually written in Python. So dependencies are actually even more, let's call it, in more cases, you see more cases where someone delete a package from PyPy, for example. And then that package is not available anymore. And the model can actually be broken by that. So dependency installation is still need to be part of a build system. Model training. So in models, one of the big differences between models and traditional code is that models should also be trained. And actually, a build system for models is not just invoked because of a new feature that I'm developing or a bug fix, but can also be running because of a new training, because the data, for example, has drifted over time. Model evaluation is another part. So if I train a model, I also need to make sure that this model actually is better than the previous version. In addition to that, I need to add a few other, so model testing is part of the evaluation, but I need to add other steps that usually I do for traditional software, but not for models. So things like functional test or integration test. Like, let's think about a model. When I'm running prediction for a model, I'm running a few processes, right? It's not just taking the data and feed forward on the model or running the actual predict function. Usually I will have some kind of feature engineering. Maybe I will even extract some features from a different database. Maybe I will even call the third-party API and enrich the data. So these processes should be tested as part of the build system. So I can even run an integration test. Afterwards, usually I will create the artifact. So the artifact can't really be just like a pickle of the model, because I do need the dependencies as well. I do need to make sure that this artifact can then be deployed in production without any moving parts. So it should be an immutable artifact. So usually what we are seeing right now is that these artifacts should be, or usually we see Docker containers as the artifact that's eventually created through that build system. And last step is version management. So models are not built once. And models have many different variables. It can be the hyperparameters of a model. It can be the data of a model. It can be the metrics of models. And all those things should be saved over time, so I'll be able to compare between different versions and reproduce the same model over and over again if needed. So that's the way I look at the build system, and I do want to show you an example of how, for example, we implemented it at Qwak. And some parts of it is even just creating the structure, the way that companies can manage models over time. So let me start by showing an example of a model. So let me just make it a bit larger. OK. So first of all, my model is a simple Titanic survival probability model, just a model that I downloaded directly from CatBoost repository of code. So basically, you can see that this model, if I look at the actual build function, so I'm getting the Titanic data set from CatBoost. Then I'm just dropping the labels for the training data and the passenger ID, that is just a random number. And eventually, I run the fit function. So this is a model, a really simple model just for this example. And this model also has some dependencies. So this model, for example, is running on Python 3.8. It uses Pandas 1.15. It uses scikit-learn and CatBoost as part of the training. So those are the dependencies that I need for this specific model. What we are trying to aim for at Qwak and what we are trying to show our customers is that you also need some structure in a way to, a new data scientist looks at the model and understand how this model looks like. Thing that usually we are doing in traditional software. So this model is divided to two different folders. The main will be the code itself and the dependencies. And in the test, I can also create integration tests. I can try to run predictions to that model as part of the build process. So you can see that in the test, for example, I'm creating a client, and using this client, I'm trying to run predict, and just checking that I actually get back the value from that specific prediction, making sure that the value in this example is above 0. So how do I build this version, this model? So basically, in Qwak, as I said before, we created this process that I shared. What will happen in that process is that first, it will spin up a Docker container based on a base image that we have. Then it will install all the requirements. So in this case, the requirements are in Conda template, but it can be, of course, any other type of package management. Then it will run the build function. So this function that you see in here that create a self.model object. It will create a container from that class, from this code with the dependencies and the class. And then it will run the test versus this container. So to start a new build, all I need to do is to run the command. Just make it larger. To run the command Qwak models build with a model that I want to connect it to and different parameters. For example, you can see that this model expects different parameters like learning rate or iterations. So let's say I want to run only 500 iterations. And I'm running across the local directory. This is the location where I have the code itself. So now what happens is we take this directory, we upload it into the Qwak platform, and we initiate a new build. So I haven't talked too much about the Qwak platform, and I won't do that in this session. But if I now go to the UI of Qwak, I will see that under this model called Titanic example, I have a new line, a new build that is currently in progress. This is the orange circle. This build is now running, and in a few seconds, or actually in this case, I think it takes around 3 minutes, this build will be completed. So for now, just for in sake of time, let's open the previous build that I ran and look at the actual process that this code went through. So by the way, I can see all the parameters that this build was using. I can see the metrics that this build exposed. Let's do it a bit larger. I can see the code that was used to create this build. So it's basically the same code that I showed before and the tests. I can see the resources that were used during the build. So in this case, it was running on a CPU, but it can also, of course, run on a GPU. And the logs will show the process that the build went through. So things that I talked with you about, things like installing all the requirements. So let's actually show you all the logs. So you can see in here, if I scroll down, that it installed, for example, different packages, the CatBoost and Python 3.8, etc. So it installed all the requirements. Then, for example, it ran the build function. So in the build function, I can see all the logs of the actual training. I can see the accuracy. I can see all the metrics that are printed during the training. After the build function, I can see that it created the serving artifact. So basically, it's a Docker creation process. Then it validating that the artifact can actually work, that there are no errors, for example, in this Docker container. And then it's running the test. So basically running an inference, getting a specific result, and making sure that everything works as expected. Only then, it pushed this Docker container to the model registry. So only if the process completed successfully, eventually I will get a Docker container that can be deployed. So if I'll go back, for example, to the build list, I can see that the current build that I just ran is still in progress. Let's click on it. And I actually see that it's now in the test phase. So probably in a second, I will see logs about the test. I can see that the test is passed successfully. And now it's pushing this artifact to the Docker registry. By the way, it's automatically cache different layers, different parts of the process. So if I'll go back to the list builds, I will be able to see that, for example, the first time I ran it, it took me 7 minutes. But afterwards, since afterwards it's shorter just because it doesn't really need to reinstall the requirements. There are things that are already installed, and I can use this cache to actually make it faster. By the way, I can see the iterations that each one of the builds ran, and I can see the metric. I think that in this case, yeah, all of them is the same metric because we're using early stop. So eventually, all of those builds stopped before the 500 iterations. So all of them got to the same metric. So this is the build process, and this is the first thing I wanted to show you and talk with you about. Once I have a new build, once I have a new version that is actually can fit production, and this is part, by the way, of the production-first approach, right? Production-first approach, the idea is that data scientists should put something in production as fast as possible. So even the first version should not be part of the product. The first version should not be as accurate as possible. But they need to make sure that this model they are trying to build, even if it's still not accurate, can be in production. And after I do this process, I can now start basically optimizing this model and making sure that it gets to the right results. So I have this build, I have the initial version. Let's say now I want to deploy this version. There are some challenges that I need to solve in here as well. So first of all, models are not accessed the same way for each model, right? I talked about the start of this session, but there are models that are more relevant, let's call it, for batch processing. So things like churn, LTV, different type of marketing challenges. There are some models that are more relevant for batch execution. There are some models that are more relevant for real-time. So usually things that are integrated to a backend. So things like, for example, product recommendation. That's a classic one. So I want to run a recommendation based on something that the customer is currently doing in my website. I need the current event, and based on those events, to give him back the recommendation. So in many cases, these are models that are more relevant as a real-time model. And some models actually are relevant for streaming use cases. So for example, let's say I have a stream of events in my application. Let's say I have an mobile application. This mobile application is sending events for different things that customers are doing. And let's say, based on different events, I want to offer promotions to the customers. So I have this stream of events. Let's say it's a Kafka. I send events over this stream, and I want a model to then get all these events and send me back predictions based on a specific set of events. So in that case, I don't need really a synchronous prediction, but an asynchronous event-based solution can actually work. So there are different type of models, different use cases. And in addition to the different use cases that models should be actually ready to do, there are different serving architectures that you need to think of. So things like, for example, how you test new models. A/B testing is something that's widely done in other areas, like, for example, UI changes. But for models, it's more complicated. Everything with data is more complicated, right? Data is something that is quite expensive to save and use, and A/B testing models is quite expensive usually. So those are other things that you need to think about. If I can test models, if I can do A/B testing, if I can maybe even choose different audiences and specific users send to one model, other users send to my previous model, and eventually test if a new version is working as expected. So those are things that you need to think about. Shadow deployment, another quite nice feature or thing that you can do is deploy model as a shadow version, just send data to that version without really changing the production, without really changing which version is responding to requests. And even talking about things that we're hearing nowadays more and more is model per customer. Many companies are starting to feel that the general purpose models or models that are trained on all of their data are not relevant anymore. Or they're having so much data that they can actually nowadays train a different model per geography, per customer, and get better results. But then it makes it way more complicated, because now I don't have only one model or two or three. I have tens of models, hundreds of models that I need to manage. So it makes this process even more challenging. And in that case, you need to think of how to shift the traffic to the right model per geography, for example. So I want to show you now an example of that. So how you can now take this artifact and deploy it based on the use case that you need. So I can go back to the platform. And in the platform, again, I can see that now I have 3 versions. These versions right now is just a model repository. So for now, I can just see for each one of the versions the different parameters. I can reproduce a version because I have the data, I have the configuration, I have the code. But I can also deploy a version. So if I click on deploy, I can choose which type of deployment is relevant. So for each use case, I don't need to rebuild my model. The process looks the same. It always creates the same artifact. Usually we'll create the, let's call it, most challenging type of model. So usually the most challenging will be a RESTful solution. So the container that is created is a web server that can serve, eventually get REST calls and give you responses. But for other type of deployments, we take use of that REST server and basically add some kind of wrappers on top. So if it's a batch execution, we take the data and we send batches of data to that REST server. If it's a streaming use case, we have a client that consumes data from Kafka, for example, and send that to this model. So I can now choose which type of deployment I want. So let's say I want a real-time deployment. I can choose if I want to run on a CPU, how many initial resources. Of course, there are auto-scaling solutions on top. Or if I want to run on a GPU and what type of GPU I want to run on. So let's choose for now to run on one pod with one CPU and 2 gigabytes of memory, and click on deploy. So what now will happen is that this model will be deployed, in this case on a Kubernetes cluster that serve this infrastructure. And this process takes around a minute and a half, and then you get back this RESTful API that you can use for prediction. So if I look at the overview in about one minute and a half, I will be able to see that there is a new version in here that I can now run predictions on. And in the interface, I will be able to see what I need to do to actually run the predictions on that model. So what I will show you next is how I can then take this, for example, model and add a new version, and then decide how to shift traffic between the different versions. So those are things, again, that allow you to then test different versions and make sure that you gradually moving between versions, testing your versions, and making sure that your model, your production, is actually working as expected. So I now have this model deployed. I can go to the overview screen and see that I have a deployed version. And I can see all the metrics of this version. So I can see the throughput, I can see the error percentage, the latency, utilization of CPU, of memory. If I was having a GPU, I would be able to see the utilization of the GPU as well. And actually, I have, at least should have, like a client that tried to send predictions to this model. So probably in around a minute, I will start seeing metrics for this model. But I can also show you the interface, for example, of how to actually connect with the model. So as I said, this model now is a REST API. It's a real-time deployment. And this is an example of how I can use a Python code to actually run prediction. I can also use other languages like Java, like Go, like REST, call. But again, this model eventually is now something that the backend should call. And the backend usually is written in different languages than the model itself that will usually be in Python. So if I'll go back to the overview, let's see if I have some traffic in that model. Yes, I do. So I can see now the average throughput of the model, the response time of this model, and actually see many other things, like even analyze all the data that went through that model, all the input features, all the predictions, and make sure that the model works as I expect it to work. So let's try to deploy another version. Let's see what we can do, for example, for A/B testing or for shadow deployment. So if I'll go back to the builds, I can now see that I have one version deployed. I can choose another version and, for example, choose to replace the current version or add a new version and deploy that as, for example, a shadow. So now 20% of the traffic will be directed to the new version, but still all the requests will be responded by the current version. So it won't change anything in my production environment. The backend will still get the same results, but I can test a new version and make sure it works as I expect. I can test the new version versus the previous version and see if there are any statistic differences between the two. Or I can decide not to do a shadow variation, but move 20% of the traffic to the new version and 80% to the previous one. So if I click on deploy, and I'll go back to the overview. So again, in about a minute and a half, I will see that in addition to the yellow throughput over time of this version, I will see another new line of throughput over time. I will see that 80% of the traffic still goes to the previous model, and 20% of the traffic will go to another model. So now I can actually test this model, make sure it works as expected, or even direct specific audiences to this new version, and make sure it works as I expect it to work. So let's wait just for a couple of seconds to see this model deployed. And then once it will be deployed, we'll be able to actually see that and see how the traffic shifts now to this model as well. By the way, in the analytics part, the one I showed you before, I see all the predictions. So I can actually directly from here compare between different versions. I have this query engine that I can use. I can see what are the statistics. I can see what are the differences between different versions. And I can even visualize the distribution of features for each one of the versions and compare them and making sure that the version that I'm currently running is giving me the right results, is getting the right input features, is eventually outputting the right predictions. So all those things can be automatically visualized directly through the environment. So I'm going back to the overview. Let's say if it finished deploying. And so for now, let's just continue with the presentation, and then I'll go back afterwards. So I think those are the most of the things that I wanted to talk about, showing you the build system, showing you how to deploy models, how to adapt to different use cases, and now it's the perfect time for any type of questions that you guys have, and even share some of your use cases. So any questions about the things that I've talked about? There's a microphone over here, so if someone wants to ask questions, feel free to go to the microphone. OK, so let's see now the traffic split and see if I have that already deployed. It's still deploying, but I will keep that in the background, and we'll see that probably in a few seconds. So any questions? Yeah, go ahead.
Yeah, thanks for the presentation. Really cool. Obviously, you make this analogy between ML model development and standard software development. What about kind of CI/CD practices? Like I see the way you're deploying here is you kind of use the CLI, but suppose I change the code of the model, I commit the change. What happens next? Is there kind of, do you have integration with the SCM? And yeah, just curious.
So that's actually a great question, because I love this analogy between traditional software and machine learning, because I do believe that eventually it's the same. And eventually, even more than that, I believe that eventually more and more traditional software will move through to being models. And actually, we're seeing companies right now that are going for more like software 2.0 models first approach. And CI/CD is part of it, right? Because models are actually more complicated in that way than traditional software. Because for traditional software, eventually, it should be built in one case. If there's a change in my repository, so if I add a new version and change, eventually push to my main or master branch, I want an automation to run, take this code, build it, and deploy that in my environment. And for models, it's a bit more difficult, because there will be two different, even three triggers, no, two different triggers for models. One will be a code change. So I do still want to build a version once my code change and I upload a new version to my, for example, Git repository. So this is one reason for a CI process to start. The second reason is if, for example, my model needs to be retrained. That's not only because of a change in the code, but also because of a change in the data. So if, for example, I have a drift over time, or I have a new, I need to train because I have some big changes in my data, I need that to also trigger the same CI process. So what I do believe in is that models and this process of building models and deploying models should be able to be invoked based on an API. And once you can invoke it based on an API, you can pretty easily integrate that to any CI system. And I do believe that eventually companies have their CI systems, and in many cases, at least, especially when it's invoked based on code change, should be the same CI system. So even in this case, so I showed the CLI version of how to build new version, but eventually it's an API, it's an SDK, it's eventually like an API. You can run that for different languages, but still even just a CLI can be just running as part of the CI system. This build process can be automated through a CI. The deployment process, even things like shadow deployment or just 20% of the traffic shift, can be part of a CI and a CD solution. And by the way, we're actually seeing now in the graph that the new version is now alive. So we have 20% of the traffic in the new version and 80% still in the old version. And that can be automated. And then, for example, based on a human intervention, we can change that to 100% of the traffic or automate after an hour or something like that. So yeah, I agree with you. And part of it should be automated. And the build itself and the deployment should be able to do through a CI system.
I would like to know how you deal with the beginning of the phase for a data scientist, so the exploration phase. if I have no idea which model I want to choose and have to train 20 different models just to try out which one fits, would this create 20 different builds which I have to keep track of and debug, or do you have like a, basically say, a Jupyter notebook interface for that? How does that work?
So great question, and I'll start by saying that the major focus of Qwak is the production phase, and that's where we are focusing most of our efforts in terms of solutions for data scientists. But I do believe that they are great, first of all, research and development tools for that. So things like, for example, Jupyter Notebook are still something that data scientists should work with, especially during the research phase and first visualization phase in understanding the data. But if I'm going back to the production-first approach, I think that one of the challenges with Jupyter Notebook, for example, is that it can be actually quite easily, you can have a lot of mess in a Jupyter Notebook, and managing that over time is quite complicated. And what I usually recommend to data scientists is to still try and work with classes, with functions. So even if you use a notebook, the notebook is a great orchestrator. You can run different cells, you can change some parameters, but the class itself, the model itself, at least I believe, should still be in a Py file. It should still be a Python class. So, for example, the same code that is running in the notebook as part of the orchestration can then move to any type of other orchestration, and you won't change anything. The classes are still the same, the functions are still the same. So for the visualization part, for the exploration part, I do believe that the notebook is a great solution. But then once you want to run other type of jobs, let's say you want to run actual experiment tracking, do that on a notebook and save the results is quite frustrating. You need, like, where can you do that? In an Excel? So there are tools for experiment tracking. You can use the build system to run different experiments and compare between different jobs. Running hyperparameter tuning jobs. And again, something you probably not run on a notebook, especially if you have large data sets. So you still probably need like a build system or any kind of remote system to run this hyperparameter tuning job and test different parameters. So I do believe that running on Jupyter or even on IDEs. IDEs are still great solutions. Things like PyCharms, VS Code are great solutions for the experiment part, but it's not instead of a notebook, right? Exploration is still easier on a notebook. So those are things that are part of the process, and data scientists should try to move to production as fast as possible. So I believe that once they are starting with their experiments, even for the first version, let's try to build to production, make sure it works, and then keep iterating. Again, make sure it works and keep iterating. The same way with traditional software. I don't want to build one big software and that's it, and move it to production only at the end of that. I will probably start by building the API. Then I will add some, an MVP solution. Just then I will add more and more features because I do want to make sure that it works as I expect and give me the right metrics. Even infrastructure metrics like latency. So this model responds in 8 milliseconds. But let's say my use case needed way faster. Then I have a problem. The solution that I've used, let's say CutBoost, is not good enough for my use case. So those are things that you need to think of ahead of time and make sure it works and make sure you test it even before you build your final version. Great. So thank you, everyone, for joining this session. And I hope you enjoyed the conference. We are at the end of the conference, or like a few hours before it ends. So thank you, everyone. And if you have more questions, feel free to come to our booth or even scan this QR code and schedule a meeting with me or someone else from the team. And thank you, everyone, for joining.
Yeah, thank you very much, Yuval.